magnet and metals. We talk about magnet as material that can attract other metals, okay, in our previous class, and then we looked at 3 classes of magnet. Today we want to look at materials that are attracted by magnet and those that are not attracted by magnet. Materials that are attracted to magnet are known as magnetic, and those that are not attractive are known as non-magnetic. Examples of magnetic material: you have iron, steel, nickel, and then cobalt. Why for non-magnetic, you have paper, wool, fabrics, and other non-metals, okay, like sulfur. And then some metals are not attracted by magnets. Example of that metals are gold, silver, aluminum. They are not attracted by a magnet. If you place a sheet of aluminum between the opposite poles of 2 magnets, what do you think will happen? Aluminum as a metal has a special property with magnet, okay? If I take an aluminum and place it in between poles of 2 magnets, the aluminum will behave as if it wants to be attracted by the magnet, but it will not stick to the magnet. It will only turn, it will move and arrange itself in the way the force of the magnet is arranged. Such kind of material like this aluminum, we say they are paramagnetic. Say paramagnetic. Whereby the metal behave, it moves inside the magnet, but it does not attach itself to the magnet, okay? But we classify aluminum as non-magnetic since it is not attracted. All right, now let's look at magnetic and non-magnetic materials here. Let's sort them out. Look at the bottle opener. What do you think? Magnetic, yes. What about the needle? Magnetic, yes. Glass, non-magnetic, correct. Wool, magnetic or non-magnetic? Non-magnetic, correct. Scissors, magnetic. What about bottle? Non-magnetic. Paper clip, magnetic. Leaf, non-magnetic. Table, non-magnetic. What about screw? Magnetic. Eraser. Is eraser magnetic? No, it's non-magnetic. Knot. No, knot is magnetic. Yes, very correct. Magnetic forces can pass through non-magnetic materials, including skin and bone. So what this is trying to say is that if I put a magnet and I use a paper to block the magnet, and then I take this iron knot you are seeing here, after putting paper to block the magnet, and I use the iron knot and put behind the paper, the magnet will still attract the knot because of the force. The force is greater than the paper, so it will pull both the knot closer to the magnet, and then for that reason the paper will not be attached to the magnet also. But if I remove the knot, the paper will fall off, okay? That is how powerful magnetic force is. We can use magnet to sort metals. Why? Because some metals are magnetic, others are not magnetic. For example, in aluminum industry, we use magnet to sort out iron and leave aluminum behind so that we can recycle aluminum. Why do we need to recycle aluminum? Aluminum is non-magnetic metal that is light, easy to shape, and does not rust. Many of the cans we use for drink are manufactured from aluminum. They are made from aluminum. It is very difficult to produce aluminum from aluminum raw material, which is called bauxite. All right, why? Because to produce aluminum from aluminum raw material, which is called bauxite, is very expensive. You need a very high energy. Let's say you need like 3,000 kilojoules now to produce 1 ton of aluminum from raw aluminum material, which is called bauxite. If you decide to recycle material, that is, you now pick the used can, instead of using 3,000 kilojoules, you will now use something like 1,500 kilojoules. If it is, which one will you use? Instead of wasting so much energy and time, it's better to use less energy and less time, okay? That's why people prefer to recycle aluminum. Other cans are made from steel or tin. These metals are magnetic, so magnet can be used to remove them from the recycle waste, leaving the aluminum behind for processing. Let's look at this diagram below. Look at this diagram below. There is a mixture of aluminum and iron. We want only the aluminum. So what do? We allow the aluminum and iron to pass through two stages. The first stage, you see what? A magnet there. And then the second stage again, that is the third stage, you see another magnetic head. Now, the first one will filter almost all the iron out before it is not crushed. By then, it is not very smooth, a bit smoother, okay? It will now pass through the second head. The remaining smaller iron that have not been removed will not be removed also. So, after the third stage, what we have is basically aluminum. And then we mold, we heat it, we melt it, we scale it or we sell it, and then we convert it back to aluminum can again, as you can see in this diagram. Okay, now where do the cans come from in the process? The cans that are used in this process are gotten from, if you observe people that come to pick your waste at home, observe it very well, you see they used to select these cans and keep them separate. Okay, when they get it, when it's not many or it's not bulky, they'll go and sell it to these companies. This company will now recycle it to new ones again. Okay, why do you think there are two magnetic heads? You already know why there are two magnetic heads. Is it not to properly remove all the magnetic materials such as iron and steel from the aluminum, so that only aluminum will be left? Is it not? Yes, so that you don't end up producing aluminum that has iron. Okay, now I want you to watch this short video. Pay attention to materials that are attracted by magnet. Also pay attention to the magnetic force, how powerful it is. Okay,
some materials are magnetic and some are not. A rubber made of rubber is not magnetic. A spoon made of metal is magnetic. A candle made of wax is not magnetic. A nail made of metal is magnetic. A spoon made of plastic is not magnetic. Paper clips made of metal are magnetic.
A magnet is something that can attract certain metals. It has an invisible force that pulls the metals to itself. This force is called magnetism. Some rocks are natural magnets. Here's a story about magnets. Long ago, a boy in ancient Greece walked across a big rock. But as he walked across the rock, it pulled the nails right out of his shoes. His shoes fell apart, and the nails stuck to the rock. We don't know if this story is true or not. But we do know that the word magnet comes from the name of a place, Magnesia, where some of these natural magnet rocks were found. Does a magnet attract all kinds of metals? No, there are only certain metals that are attracted to a magnet. They are iron, nickel, and cobalt. These metals can become magnets. Now observe carefully. You can see that more iron filings are attracted to the ends of the magnet, while less iron filings are attracted to its middle. This shows that strength of this magnetic field is more at the ends and less at its center. Let us now learn how our Earth behaves as a magnet. Have you ever seen a compass? A compass is a tool that helps people know which direction they're going in. A compass has a needle that has been turned into a magnet. You can turn something into a magnet by rubbing it with a magnet. The needle in the compass can spin. The needle spins such that when it rests, one end of the magnet points toward the north and one toward the south. This works because the Earth is like a big magnet. There is iron inside the Earth. That gives our planet its magnetic field. Can magnets pull through solids? Yes, magnets can pull through solids like paper. As we've seen, magnets are useful, powerful, and sometimes amazing.
Welcome back. I believe you now have learned and you now know that magnet attracts some metals but not other metals, okay? And you also know that magnet can be used to separate magnetic from non-magnetic metals. Now let's look back to what we've learned in this series. We talked about a circuit. We say a circuit is a closed path that allows electricity to flow through it. Circuits are built by connecting components to form a complete circuit. Is it not? Components like wire, switch, battery, and then of course your bulb or your light bulb. We say electrical devices work when they are connected to a complete circuit, okay? And we say if there's a break in the circuit will not work. We also say that metals such as iron and steel are what? Magnetic, while aluminum, copper, and gold are non-magnetic. That is, they are not attracted by magnets. We also say electrical current flows through the circuit, and then the flow of electrical current can be described as movement of tiny particles from the battery through the circuit and back to the battery. I would say it is what? A loop, alright? It's repeated until you put a break before it will stop. We also talk about magnets exert pushing and pulling forces, which pushing forces repel, pulling forces attract. Pushing forces because the two poles are the same. If I pick a north pole and a north pole, it will push each other. So we have a pushing force, which is called a repellent or repel each other. Alright? While we have a pulling force, like a north pole and a south pole, or a south pole and a north pole, they will attract each other. Alright? So we concluded like poles repel or like poles attract. I take it again. We concluded by saying that like poles repel or like poles attract. Again, like poles repel or like poles attract. And it's the same thing for electricity, okay? That brings us to the end of today's lesson. I want you to do your assignment carefully and submit and stay safe.